So what you're presenting here sounds as if it's always been the standard of practice, but the reality is, people there's baggage with the word structure, and we have in-stream structure expectations when you work with other agencies, when you do consultations, when you apply for permits. What's been your experience working through this process, Scott? You've planned a lot of these projects from start to finish and have applied for permits. Are you able to use this type of design package and get through that process fairly well?
Yeah, the short answer is yes. The longer answer is is the old it depends. Here, so I guess to make it personal, here in Utah and some of southern Idaho where we work, we've been really fortunate to work with folks in, for example, regulatory capacities who have been I think pretty great and on the forefront of embracing this as a viable and legitimate restoration technique. And once we had conversations with them about sort of the same kind of rationale that I just outlined here about having, why it might actually be okay to work with this, what some people would say sloppier, but I would just say maybe less precise approach to permitting and design, why that's okay. And it's okay because we've identified risks. We've, clearly articulated what we think will happen. We've identified the trajectory of, the restoration trajectory, linking our condition to our objectives. And once we have that conversation, in my experience, at least, that's been pretty good at opening doors to understanding why it's okay to, for example, identify where you'll put the complex, but maybe not where you're going to put every single individual structure, down to the meter scale.
And so you haven't encountered anybody pushing back saying, no, you need to have an engineer's stamp and some AutoCAD drawings for this.
Well, so maybe not any, but but it hasn't been. There certainly are some places where the engineer stamp is required still. I would say though, generally, it feels that there's been a pretty good sort of, although maybe slower, sea change that accepts that that is not always as important as we thought it was. There certainly are still places that are, or individuals and agencies that are asking for the individual dot on the map. And in that case, we can do that. It's not that we can't do that. We certainly can put dots on a map where we want to build our structures. Part of our goal in designing complexes is to continually remind ourselves that the importance of any single structure really isn't that big. What's much more important is how many structures you built, over what spatial extent are you working. And so there is admittedly sort of a hidden objective in this approach, which is to keep our minds on the scale that really matters without getting sucked into the individual structure scale. Because as anyone who's gone out there and built these has probably found, when you get out there and you get a bunch of really enthusiastic people building, the structure might end up being 5 feet upstream or downstream from where you put it. And I think, would argue that that isn't really where we should be, spending a lot of time thinking about or worrying about whether it was here or 2 meters upstream or downstream. And so that mentality definitely is still out there, but having a dialogue and providing the rationale for why we don't think it's necessary, I think has actually moved the conversation pretty far.
So there's a learning process that's still going on as we work with our collaborators, our regulators, and we need to be patient as we work through that.
Absolutely.
So the next question has to do more specifically with, using structures in an incised reach, and the idea of, do we need to somehow measure stream power or model, runoff events so that they don't all just blow out in the first storm? How do you know what level to design for, whether or not you need posts in a BDA or something? What's the thought process there?
Sure, that's a great question. And there's a couple ways to tackle it, but I think the the best way, really, in some respects, is to think about going back to something we've talked about, which is pilot projects. If you have a lot of uncertainties, whether they're driven by the system itself or maybe even risk or infrastructure type concerns, you don't need to go big right off the bat. Everything we've outlined so far, from the planning and design, and as we continue through to implementation, is not really heavy on cost. And so there's a trade-off when we get sort of going down the road about thinking we need to model this. One practical way to approach it is to simply ask, could I learn a lot of this information by doing what amounts to a mini experiment, where I go out and I build a handful of structures, maybe 5, 10, 15, whatever it is, that are going to help me answer this question. Because modeling it, there are a ton of things to model, and the well-known phrase of, all models are wrong, some are useful. And so what can we learn by doing these things on the ground immediately? If you're concerned about whether or not you need posts in your pilot project, build some that use posts and build some that don't. If you don't know whether or not all your structures will blow out, well, then it's probably not a good idea to implement it in a very large project. Just build a small project. And if they all blow out, you've learned a heck of a lot. And I would wager that you might have been able to still build a handful of structures, a pilot project, for about the cost it would have taken for you to model all of those things. And so there's a couple different ways we can approach it, but I think pilots are probably one of the strongest ways to actually get some information back, some immediate feedback.
Great, thank you.
Hey, Jeremy.
Yeah, go ahead, Joe.
Just piggybacking on the pilot comment. Also, if things aren't working as expected, Scott, can you just comment on, how difficult these things are to remove? You put a pilot in, you don't like how it's going. Is it pretty hard?
Oh, sure. No, it's not. Removing structures can absolutely be done. If for whatever reason it becomes an issue, and I imagine we'll have some discussion about this when we talk a little bit more about water amounts, rates, and discharges, downstream delivery. If you need to, you can always take them out. It is not cumbersome. If that is the question or the sort of concern.
That's a great point, because opposed to what we normally do, which is we invest a lot in individual structures. We designed them. We spend a lot of money keeping them in place. The consequences of being wrong are very high. But if we've spent a minimal amount of time on design, it costs us mainly labor to put these low-tech things in. They can also be unwound if we have undesired things that we didn't expect to happen. So that's a great point.
Not to mention
let's
the
keep moving.
structure's not the goal, right?
Yeah.
The process is, right? So
process, right. So let's keep moving through. We've got a ton of questions. If we don't get to them, I'm sure Scott will keep himself busy helping answer these this afternoon. But I want to get to this question about, is very specific to systems that are highly manipulated. So a lot of our waterways have dams, reservoirs that have starved the system of sediment. How do you deal with that when, admittedly, you're trying to get the system to a grade and raise back up and maybe activate some of those inactive areas?
Sure. Well, I think that those sorts of considerations, I guess the first place that would probably pop up for you would be in the planning phase, when you're assessing your recovery potential. So if you know that you're operating in a system that has alterations to, in the case of dams, both the flow and sediment regime, and then when you get to that part of the planning where you ask, do we have what can we do in terms of geomorphic work? What can the system achieve on its own? You're going to have to address that there. And so ways to think about it, or that's going to influence both, I guess, the answer to, does the system have the power to do the work? And it's also going to influence your recovery potential. If you're sediment starved and you're working in an incised setting, maybe instead of shooting for a target where you get back to that initial floodplain surface and reconnect, maybe you're having to think that you're going to widen your channel. You can still do that, but really you might end up shooting for, let's say, more of a stage 8 target, whereby mobilizing some of those existing sediments in the bank and reworking them, you can get some of the benefits of a wider channel that can still accommodate the growth of riparian vegetation and anastomosing conditions, but within a newly developed inset floodplain, instead of getting back to your original surface would be one trajectory that might be more realistic if you know that your sediment source is limited due to upstream alterations.
But isn't that erosion, Scott?
I'm afraid that would indeed be, it would be erosion at a structure scale, but I'm glad you brought that up, because one thing that pops up oftentimes for us is we tend to, as we've talked about earlier, treat things in sort of black and white categories of it's erosion and it's bad. But because of the scale we're hoping to work at, because of the number of structures we're hoping you all design and build, local erosion at a structure scale doesn't mean that, you know, your downstream user is just going to experience massive channel aggradation and then flooding or whatever the concern may be. This, you know, sort of building this many structural elements within a reach, I would wager that even if you see erosion caused locally by individual structures, the net delivery of sediment downstream is you're probably going to be storing more sediment in your stream than you're going down at the downstream end.
Yeah, that's a great point. And I, again, go back to that stream evolution model. I don't know what I think those types of illustrations are so useful, right? Because you're making decisions about how deep is the trench that you're in, right? Mm-hmm. If you can nudge back up, you know, in other words, maybe you're a stage 1, you just have a nice channel that does access this floodplain regularly. And if you add beaver dams to that, you could flood a massive area right out of the gate. But if you're 10 feet down, it's unlikely in our lifetime that you'll be able to get back to that. And so you're talking about maybe building that new inset floodplain, accelerating that evolution process that would have taken geologic time to go through, but we're gonna really enhance that. So let's go ahead and turn it back to Joe. Thank you so much, Scott, and get everybody to lunch on time.